Hey peeps, it's Sophie here with Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're dealing with the Grade 11 2018 Physical Science paper, and this is question 12 on current electricity. Okay, so it says, consider the circuit diagram below. The internal resistance of the battery and any resistance in the wires can be ignored. Okay, so we can see here that there is some sort of source, so that's probably a battery, and there's this parallel connection here. Okay, consisting of resistors here and these resistors in series. And this is in parallel with all of these. Great. So the first question says, calculate the value of resistor R if the total resistance of the circuit is 4.8 ohms. Okay. So they've given us the total resistance of the circuit, but we know that because all the resistors are in parallel in this circuit, that the equivalent parallel resistance is going to be the total resistance of the circuit, because that's taking into account all the resistors. Okay, so I'm just going to actually circle, or put a dotted line around our parallel part, so that you can see the current will come through here and then it'll split into these two paths, which is how you know they're in parallel. Okay, so let's get started. So we're going to start with the equivalent resistance formula because we know that the total resistance is 4.8 ohms. So we can start with the parallel resistance formula, the equivalent resistance in parallel formula, and that is 1 over the total equivalent resistance is equal to, and then we look at all of the resistors that are in parallel. So we know that there's a 4R, and then we know that there are a few resistors in series in that one little parallel split, and that is R plus 2R plus 3R, which is 6R. So we have a 1 over 4R here and a 1 over 6R here. That's still 1 over 4.8. So then we can solve for R, and that is 2 ohms. So we know that all of the R resistors are, well, all of the R terms in the resistance values are 2 ohms. Okay, cool. So then the second question says, calculate the reading on the voltmeter if the current through the 4R resistor is 1.8 amps. So they've given that the current going through here is 1.8. That's just this current. So then naturally a good starting point would be to calculate the current going through the other loop. And then once we have that current, we can work out the voltage that is going over the 2R resistor, which is the voltmeter. So let me erase some things for space. It's going to be a few calculations. Okay, so we know that the R value is now 2 ohms. Okay, so if we work with the 4R resistor and we solve for the voltage through there, we know that voltage in a parallel circuit is equal. So the voltage across this is going to be equal to the voltage across this whole parallel here. Okay, so let's start with that. So we are working out the voltage through the 4R resistor, and that is equal to that current that they've given us times the resistance of the 4R resistor. Okay, so that's V4R is 1.8 amps, which is what they've given us, and then the resistance of the 4R is just 4 times 2 ohms, and that is 8. Okay, so then we get a V4R to be 14.4 volts. Okay, so now we know that that is also equal to the voltage over those other resistors. So I'm just going to write over the 6R because that's the cumulative resistance of all of these things. Okay, so then we can start with that. We can say that V6R, the voltage of 6R, is equal to the I across, that's going through all of those resistors, and then times by the R of all of those resistors as well. So we know that this is 14.4. We don't know what the current value is, but we do know that the resistance is 6 times 2, so 6 R times 2 ohms, which is R, and that's 12. And then that gives you a current of 1.2 amps. So now we know that the current flowing through this section is 1.2 amps, which means it's going to be the same current that is flowing through just the 2R resistor, and that's where the voltage is over that we need. So then we can say that the voltage across the 2R resistor, which is the voltage we need, is equal to the current, which is 1.2, and then times that resistance of, well, the resistance of the 2R. So that is 1.2 times 2 times R, which is 4. And that gives you a voltage of 4.8 volts. So that is the voltage across, well, that is the reading on the voltmeter. Okay, so the next two questions are theory questions. No, they're not. Let's do the energy question first. And let's just erase this for space. These current questions are quite long. Okay, so 12.3 says calculate the energy converted in resistor 4R in 2 minutes. So we know we're working in SI units, so the time is actually in seconds, so that's 120 seconds. That's change in time. And then we know that the energy, or W, is equal to the power times change in T. So that is also expressed as current squared times resistance times change in T, where this part here is power. Okay, so we know the current going through that 4R resistor. We were given it's 1.8 amps, so we can just sub that straight in. We know the resistance is 4 times R, which is 2, so that would be 8. And we know that the change in time is 120 seconds. So that gives you an energy of 1036.8 joules. And joules is the unit of energy. Okay, so then it says that the 4R resistor is replaced with an ammeter. So let's think about what is happening here. So now the 4R resistor is basically going away, and that is being replaced by this little ammeter here, traveling in series. So this part is not here. Okay, so it says, how will the reading on the voltmeter be influenced? Write only increase, decrease, or stay the same. Okay, so what happens with ammeters is because there's such a low resistance, current is going to favor the path of least resistance. So current is going to only flow through the ammeter. So current is going to favor this direction, which means if there's little to no current flowing through this parallel section here, the reading on the voltmeter is going to decrease. So the answer to 12.4 is decrease. And then it says explain your answer. We've just explained it. So current flows through the ammeter because the ammeter resistance is very low. And then it shorts out the parallel part of the circuit because all current's flowing through the ammeter. And that is why the voltage would decrease. Okay, so that's it for this question. But before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. Also be sure to visit our website for more of these epic tutorial videos. And if you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. But until the next time, stay epic.